Alright, you guys, so let's go ahead and reverse this process. What we're going to do now is, rather than getting given an equation and finding a graph from the equation, we're pretty much working in reverse. You already have a picture, and we got to find the equation that fits that. So essentially we got to find A, B, D, and C. Alright, and then use our knowledge of cosine. So here's how we're going to do this. Again, I think the easier of all these things is the A and the C. So it all begins by finding where the equilibrium point is. So looking at this graph, it's topping out at 7 and it's bottoming out at -3. So if I average those, right, so there's basically 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? There's 10. Half of 10 is 5. So basically, right, 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5 basically tells us that our equilibrium is occurring at 2. So I've just completed two things there. Number one, we now know that C is equal to 2. And then number two, we know that A is equal to 1, 2, 3, 4, 5. So A is equal to 5. So we're halfway there. So we still need to get B and D, but we now know what A and C are just by finding our equilibrium. Now to find B, B is all about the period. All right, we know that our new period is going to be 2 pi over B. So if I can find what the new period is, I can basically solve an equation and find the B that I'm looking for. To find period, all you have to do is basically look at where things start to repeat themselves. And we have lots of repetition here. So we can basically go from peak to peak. We can go from valley to valley. We can go from crossing the equilibrium in a downward motion to crossing it in a downward motion, or from an upward motion to an upward motion. There's all kinds of ways to do that. It just constantly keeps repeating. But how about I just go from peak to peak or valley to valley? This is occurring, hopefully you can see this. This is occurring at 3 pi over 2, and this peak is occurring at pi. So to figure out how much of my new period is, just take those two things and subtract them. So 3 pi over 2 minus pi is the same thing as 2 pi minus 2, which basically gives us pi over 2. So our new period is basically pi over 2. Okay? And again, you could probably see that I did it the hard way there, but notice we're at a peak at 0 here, and then, we're at a valley at 0, and then we're a valley at pi over 2. So you could have just seen it right there as well. So no matter how you cut it, right, even up here, 3 pi over 4, right, minus 3 pi over 4 and pi over 4, right? That's 2 pi over 4, which is still pi over 2. So there's lots of ways to see what that new period is, but we're still not done, right? So my new period is pi over 2, and we know formula-wise it's equal to 2 pi over B. So do a quick cross multiplication. We get B times pi is 4 pi. Divide out the pi's, and we got that B is equal to 4. So we are done. So find your period, stick it into our formula for new period, and you can find your B. So D is a little tougher, all right? And what we're going to do for D is we got to really understand what a cosine graph basically does. And so for a cosine graph, what it essentially does is it usually, under normal circumstances, it starts at a high point, right? Midway through the period, it goes at a low point, and at the end of the period, it's back at a high point. So when we go look at that, let me highlight this in red, that action is occurring pretty much right there, right? So here's your y-axis. So I can see what's happening is it looks like where the peak usually occurs on the y-axis, it's now occurring over here where we have moved over pi over 4 lengths, because that's pi over 4. Okay? So it looks from this graph, right, that that D is pi over 4. Everything has been shifted pi over 4 units, because again, we usually are on the y-axis at a peak, but this peak is happening, right, shifted over a little bit, and that's happening at pi over 4. And just looking at that graph, right, that graph right there in that little segment is exactly what a cosine graph should look like over one complete period. Alrighty? And so there you have it. We got them all. So putting this together, RF of x is 5 cosine of 4 parentheses x minus pi over 4 and then plus 2. Alright, and so there would be the guy that fits that data set. Of course, you can put that on your calculator and kind of see that your picture on your calculator matches that, and everybody will be happy. Alright, so what about the next one? Same thing. Alright, so again, let's start by trying to find that equilibrium. We're topping out at 1 and we're bottoming out at -7. So 1, 2, 3, 4, 5, 6, 7, 8. Half of that is 4, so 1, 2, 3, 4. Our equilibrium is occurring at y equals -3. Alright, and so our amplitude, we're 1, 2, 3, 4 above that equilibrium, 1, 2, 3, 4 below that equilibrium. So we now know that A is 4 and our C value is -3. So we've got that base pretty much covered. Okay, and then our next item up for bid is to find B. So we know that the period that we have is 2 pi over B. So how do I find this period? Well, again, we can go from high point to high point, low point to low point, or we're going down through the equilibrium and down through the equilibrium, right? So there's a lot of places to get that. I'll go high point to high point. So this seems to be occurring at 2, and this seems to be occurring at 1, 2, 3, 4, 5, 6, at -6. So it looks like we have a period of 8. Same thing down here, right? 1, 2, 3, 4, 5, 6, 7, 8. And by the way, the numbers here are nice and neat. They don't involve pi at all. They're just nice, simple integers. Okay? So our period is 8. So that gives us the information to solve for B. Do a quick cross multiplication. We get 8b equals 2 pi. Divide both sides by 8. And we get that B is pi over 4. So there is our B. What about D? Well, again, if we recall for a sine graph, right, what a sine graph usually does is it starts at 0, peaks out, comes back through the equilibrium, bottoms out, and comes back to equilibrium. So it usually starts, right, its period usually starts along the equilibrium. And so you'll notice that this right here mimics what's supposed to be happening at the equilibrium. So that's basically telling us that D is equal to 0, right? We're not shifting this left or right, because that behavior that usually happens along the y-axis is still happening along the y-axis. It's just been shifted down 3 units. So our D here is 0. So there you have it. So our function is our A, 4, right, times the sine of our B, pi over 4 times x. There is no D. And then plus C, well, it's actually -3. And so there would be the curve fit for that function that we have. All right? And so that's just working in reverse, how to find our A, B, C's, and D's from a graph. All right? So keep on practicing, and we will talk later. We got one more thing to do, and you'll see that in another video coming soon.